Alright, so we've talked about this briefly, but now we're going to get more in depth, converting between rectangular and polar coordinates. Let's talk about polar to rectangular first. So if we have our point at r comma theta, we need to figure out what x comma y will be. So we're going to use the fact that we have a right triangle in here. And on our right triangle, we have x, y, and we had r up here. We know what theta is and we know what r is. So let's say, for example, we're at the point, let's say we're at 30 degrees. What I'm going to do then is use my right triangle. So I'll just sketch one real quick here. Make this 5, make this 30. X will be the adjacent side, y will be the opposite side. We're going to use the cosine of 30 is equal to x over 5. And the sine of 30 will be equal to y over 5. So let me just erase a little bit here, give me some more room to work. Oops. Alright, so once we figure that out, I'm going to solve for x and then solve for y. To solve for x, I'm going to multiply both sides by 5. And I'm going to multiply both sides by 5. So I get x equals 5 cosine of 30 and y equals 5 sine of 30. So plugging that into my calculator, we get x is 4.33 and y is 2.5. So we have the point 4.33, comma 2.5. To go from rectangular to polar, we have our point up here. This point is xy. We want to go from xy to r theta. So once again, we're going to use a right triangle, and you can already see that on here. We need to know what the angle between these two legs, or this leg down here, and the radius is, and we need to know the length of the radius. The length of the radius is easy. We'll do x squared, r squared will equal x squared plus y squared. And to find the angle, we can take the tangent of theta, remember we have adjacent and opposite, that will equal y over x. Okay, so let's take a look at this example. We have our Cartesian points, our rectangular points. I'm going to draw in the radius, and this would give us theta right here. So in order to find the radius, just pull my right triangle out here. We have 2 on the bottom, 3 going up. I'm going to take r, we're going to do the Pythagorean theorem. R squared equals 2 squared plus 3 squared. Once you solve that, we get r is equal to 3.6. And then we need to figure out what theta is. So since we have the opposite and the adjacent, I'm going to set up the fact that the tangent of theta is equal to 3 over 2, which means I'll take the inverse tangent, plug that into the calculator, and we get an angle of 56.3. So in polar coordinates, this would be at 3.6, comma 56.3. So one thing that I want you to keep in mind is that if we're given points that are in other quadrants, let's say I take the point -3, negative 4, if I take the inverse tangent of that, like I just did, your calculator is going to take a negative divided by a negative. Your calculator is going to consider that that's a positive number. And when your calculator gives you the answer, it's going to tell you that the angle is actually 53, like we got before. So that would imply that you're somewhere over here. But the point -3, -4 is there, so we'll need to make some adjustments. So here's the summary of what we're looking at. If we are given the polar and we want to find Cartesian, or find rectangular, we would find the x-coordinate by taking r times the cosine of theta. Y is r sine of theta. And if we're given rectangular and want to go to polar, we would do r squared equals x squared plus y squared, and then we would take the inverse tangent of y over x. So that's about it. We're going back to doing some basic right triangle trig. Nothing too tricky, and even if you forget that summary stuff, it's just a right triangle with the Pythagorean theorem and some basic trig.